Hi gang, so now I'll do the lower one here and we'll figure out which graph that is, and then you would pick the letter here. So first of all, to do the leading coefficient test, you need the degree of the polynomial, not the factored form, but the actual degree. So a quick way to do that is to just figure out what the first term would be for each of these forms. So like this would be 4. If you FOILed this out, this would be x to the third would be the highest term here. We're not going to FOIL all this out, but the first term would be x to the third. And since this is first degree, this would just be an x. So if you multiply all this together, 4 times x to the third times x is 4x to the fourth. Like if you FOILed all this out, that would have actually been the leading term of this polynomial. Okay, but you can sort of figure it out shorthand. All right, so it's degree 4, and we know that the leading coefficient is positive. If it's an even degree, it means it's up, up, or down, down. If what makes it up, up is if the leading coefficient is positive, what makes it down, down is if the leading coefficient is negative. And since our leading coefficient is positive, it's a positive 4, it means it's going to be up, up. So on the ends of the graph, it's going to go up and up on the ends. Now, it's already factored, so for the x-intercepts, you just have to set the x's equal to 0 and solve for them. There's no x by this 4, so we're not solving anything here. There's no x here. There's nothing unknown. All right, so we get x is 3 and x is 1. Now, this is odd, which means, so remember, how you decide if the x-intercept is even or odd is you have to look at the exponent to decide of the factored form. So this is a 3, so it's odd. It means it goes through the x-axis. This is, if there's nothing here, assume it to be a 1. 1 is odd, so it means the graph goes through the x-axis. Okay, so you know you're going to go up, up on the ends. You know that you have a 1 and a 3, and they're both odd. So you start over here, you come down, you know it's odd, so you're going to go through. At some point, you have to turn around to touch the next point. You know the next point is odd, so you're going to go through. And it's going to look like this, okay? Something like this. So when we look at the graphs, you need something that's up, up. Okay, so the only ones that are up, up are this one and this one, not this one. That one's down, down. That would mean it has a negative coefficient. Okay, and then you have the x-intercepts of 1 and 3, which would be this one and this one, right? That will be the 1 and 3. That one's 1 and 3, but it's going the wrong way. That one, there's no negative 1. Okay, so it would be graph B. So I would come down here and I would choose graph B. Okay, for that, that would be graph B. There's just one other little thing I want to say before I leave this video, is that let's say you had something like this. Okay, just because in this example there's no evens. So remember, for the leading coefficient test, you want to figure out the degree of the overall polynomial, like the whole thing. So this would be second degree. The first term here would have been second degree if we FOILed that out. The first term here would have been second degree if we FOILed that out. So that means you have 3x times x squared, which would be 3x to the 6th. So if I FOILed this whole thing out, the very first term would be 3x to the 6th. I'm just not figuring out what all the other terms are. Okay, so remember, if it's an even degree for the leading for the lead term, it's either up, up, or down, down. But since I put a positive coefficient, it's up, up. And then the exponents here, this one would give you 0. This would give you a 1. This would give you a negative 1. Now they're all even because of the exponents. Now even means that it's going to bounce when it touches the x-axis or look parabolic. Bounce or look parabolic, whatever you want to think of it. Okay, so on the ends, we know we go up, up. Now, since they're all even, watch, I'm going to bounce. I'm not going to go through. So when I come to the x-intercept, I come off of it. At some point, you turn around, you come back to the x-intercept, you bounce. Okay, you look like parabolic. You can be parabolic up or parabolic down. You can bounce from the top or you can bounce from the bottom, okay? So just remember, whether it's even or odd, that determines whether you look sort of parabolic or like linear or cubic. Oh, and then I should say that too. So, you know, since this 3 is on a third, that's why this looks more cubic as it goes through, okay? So when you look at the graph and you see like locally it looks more cubic, that's why, because that's a third degree and that's a linear over there. All right, gang, I hope that helped. And when you see this problem, something similar to this one on the test, you'll know how to do it. Okay, catch you. Bye-bye.